Now let's move on to part D. Here we still have a fraction as the integrand, but we can't apply any of the formula here directly because the function is different. Although the denominator is still a linear function, the numerator is not constant anymore. It is a linear function instead. Then for this type of function, it has a feature both numerator and denominator are linear functions. And we will need a new method to solve this type of question, which is called extracting a constant. Now we are going to illustrate how to use the new method to solve this question. We focus on the denominator, which is x. And we are going to label this one as type 1, which has the denominator containing only one term, x. And we are going to recall a fact. When we add two fractions, for example, 1 on 5, 2 on 5, since they have the same denominator, then we keep the denominator 5, add these two numerators together, finally obtain 5 on 3. If we reverse this process, then we can split this fraction into two fractions with the same denominator. Now apply this idea into the algebraic fraction 3x plus 1 all over x. Split them to 3x over x and 1 over x. Then we focus on the first fraction, cancel out the common factor. Therefore, we will have a constant 3, and the second term, keep it. It's a simplified form already. We start to integrate. This integral will be equal to the integral of 3 plus 1 over x dx. Integrate individually. First part, we will have 3x by using the power rule, and the second part by using the first formula here to obtain ln absolute of x. Finally, add c for the indefinite integral. We are going to record the key steps here. Step 1, split the fraction into two fractions with the same denominator. And then step 2, we will simplify this fraction. Then we will extract a constant 3 here. Finally, we start to integrate using the corresponding formulas. These are the key steps when we solve the first type. Let's look at the now you try question. This one is still type 1 because the denominator contains only one term, 2x. But the difference is that the coefficient of x is not equal to 1. Then we will add one step to convert it to the basic type 1. The coefficient 2 can be separated to the coefficient a half times 5x plus 2 over x. Now a half can be placed outside of the integral sign. Then we will have 5x plus 2 all over x. Now it is the basic type 1, and we are going to follow these steps to get the final answer. And you can pause the video to try on your own. Then please check whether you have the accurate answer. Now let's move on to part A. Here we still have a fraction, but the denominator has two terms now. We can't split this fraction into two fractions to get a constant, because if we separate them directly to get 3x on x plus 1 plus 1 over x plus 1. The first term, we can't cancel out the numerator and denominator to get a constant. Therefore, it will not be helpful for us to integrate this function. We are going to add one more step to extract the constant. Let's see how we can rearrange. The denominator is x plus 1. The numerator, we have x here. Then we will keep the denominator. For the x part, add 1 to make it the same structure as the denominator. And if we expand the brackets, we will have 3x plus 3. Originally, we only have 1. And in order to keep equivalent, we are going to minus 2. Then we will start to split the fraction to have 3, then the brackets over x plus 1. Then another fraction is negative 2 over x plus 1. We try to simplify. For the first fraction, x plus 1, cancelled out. Extract a constant 3, then minus the second fraction 2 over x plus 1. Now we will start to integrate. The integral is equal to 3 minus 2 over x plus 1 dx. Integrate them individually, and second one we can put 2 to front. 1 over x plus 1 dx. First part we have 3x. Second part we will use the second formula here. Get ln absolute of x plus 1. The coefficient of x is 1, so divide by 1, it's just itself. Then add c. It is the final answer. So we can see for type 2, we also have to extract the constant, but we have to rearrange the numerator first. Now let's look at now your tripart. For number 1, 2x plus 1 all over x minus 3. And here the denominator is x minus 3 and coefficient of x is 1. Then we are going to rearrange the numerator in this way. X part, put it in the brackets and then convert to the form the same as the denominator. We are going to plus 6 to make it equivalent and then add the previous one. Therefore, we will have 2 times the brackets plus 7 over x minus 3. Then you can start to split the fraction into these two separate fractions. The remaining part will leave to you. Then for part 2, we also focus on the denominator, which is 2x plus 1. We can try to make the coefficient of x be 1. We are going to make 2 outside as a common factor. A half times 3x plus 1 over x plus a half. Then for this fraction, the denominator x has a coefficient 1. We will follow the previous steps to rearrange the numerator in this way. 3 and then x part we will put it in the brackets to have x over a half. By expanding the brackets, we have added 3 on 2. In order to be equivalent, we will minus 3 over 2. Then for the original one, we will keep it here. Simplify this a little bit, then keep a half to front. Then for the fraction part, we will have 3 times the brackets minus a half. The denominator is x plus a half. Then we start to split the fraction into 2 fractions with the same denominator. I will leave the remaining part to you.